Hi everyone, my name is Charson Chen from class 11 IPA-B of SMA Mondial. For my final chemistry project, I'll be doing a video lecture about chemical reactions. We will be reviewing what we have learned with Teacher Derby from the past semester. Now, onto the lecture. Here is the table of contents of this video lecture. First, I'll be giving an overview of chemical reactions as well as explaining the basic definitions of various terms in chemical reactions that we'll be using in this lecture. Next, I'll be explaining the law of conservation of mass and why it matters in chemical reaction. Third is the general types of chemical reaction, and fourth is the continuation, which is the specific type of chemical reaction. Now, onto the overview and definitions. Okay, what do you think chemical reaction is? Or what is the definition of chemical reaction? Chemical reaction is what happens when two or more substances react together to form a new substance. Or basically, substance A plus substance B yields substance AB. Note that we call A and B reactants and we call AB the product. Next is the chemical equation. Chemical equation is the symbolic representation of a chemical reaction. Additionally, molar mass is the sum of the masses of the atoms that make up the formula unit or molecule of a substance. Mole is the amount of substances that has the same number of particles such as molecules, formula unit, or atoms. Next, I'll be explaining the Avogadro's number, which is 6.022 times 10 raised to 33. The Avogadro's number is the number of particles in 1 mole of any substance. It is used to make very large numbers easier to handle. And lastly, the conversion between moles and grams depends on Avogadro's number. Fun fact, Avogadro didn't actually discover this number. It's actually named for him or after him. Next is the units of particle, which is formula unit, molecules, and atom. Formula unit is used when a substance is an ionic compound. Moles are used when the substance is a covalent compound. And lastly, atom is used when the substance is a free element. Now onto the next slide, which is the symbols of chemical reaction. This table showcases the symbols used in chemical reaction as well as their respective definition. The plus symbol represents plus or when reacts with. The arrow pointing to the right represents yields or forming. The arrow with the delta symbol above it represents when heated yields or when heated forms. The arrow pointing to the right with elect above it represents when electricity is applied or when undergoing electrolysis. The symbol with two arrows pointing the opposite sides represents when partially ionized yields. And then there are these letters which represent the state of matter of the substance. S represents solid form or powdered form, L represents liquid form, G represents gas form, and AQ or aqueous represents diluted form. Next is an example of a chemical reaction. This is the chemical equation of the chemical reaction in the example, and this is the interpretation of said equation, which is aluminium when reacts with oxygen yields aluminium oxide. Now, this equation isn't actually balanced, so we first need to balance it because, as you can see, there is only one aluminium on the left side, but there's actually two aluminium on the right side. Now, how do we balance it? We just need to make sure that both the left and the right side has the same amount of atoms, aluminium atoms and oxygen gas atoms. Now, In the balance equation, as you can see, there are 4 aluminium, and then there are aluminium 2, 2 aluminium 2. So 4 on the right side and then 4 on the left side. The interpretation of the balance equation is 4 moles of aluminium when reacts with 3 moles of oxygen gas yields 2 mole of aluminium oxide. Now, why do we need to balance equation? Because of the law of conservation of mass or matter. Why do we need to balance chemical equations? Because we need to satisfy the law of conservation of matter, which states that matter can be created or destroyed, which is why in the chemical equation, both the left side and the right side must be equal, the atoms. Now, on to the definition or what the law of conservation of mass states. In every chemical reaction, the mass of the reactant and the mass of the product must be conserved or the same. Mass of the reactant must be equal to the mass of the product. As you can see in the example, using the previous equation, 4 aluminium plus 3 oxygen gas yields 2 aluminium oxide. Now we just need to multiply the coefficient to the respective molar mass. 4 times 27 plus 3 times 16 times 2 equal to 2 times 27 times 2 plus 16 times 3. And finally, as you can see, the molar mass of the left side and the right side of the equation is the same. Now, on to the third topic of our video lecture, which is general types of chemical reactions. Now, there are four general types of chemical reaction, and each general type of chemical reaction have their own subcategories of chemical reaction called specific types of chemical reaction. First, I'll be explaining the general types of chemical reaction and give examples as well. First is the direct combination, or also known as synthesis. Uses the formula reactant A when react with reactant B yields product AB. An example of direct combination or synthesis is Ba plus N2 yields Ba3N2 or barium nitride. And the second example is natrium when react with oxygen gas yields Na2O or sodium oxide. The next general type of chemical reaction is decomposition reaction or analysis, which uses the formula AB yields A plus B. An example of decomposition reaction or analysis is ammonia or NH3 yields nitrogen gas plus hydrogen gas. The third general type of chemical reaction is single replacement. And single replacement can be divided into two subcategories, which is if A is a type of metal, then the formula is A plus B yields product AB. And if A is a halogen, then A plus BC yields Ba plus C. An example of single replacement reaction is Ba plus Na3N yields Ba3N2 plus Na. And then Cl2 plus AlBr3 yields AlCl3 plus Br2. But remember that Ba plus Li3N can also become no reaction. This is the reactivity series of metals and halogens, and how we know if an element is metal or halogens, so that we can follow the rules that have been stated in the single replacement reaction. There's also the 7 diatomic free elements that we need to remember. The fourth and last type of general types of chemical reaction is double displacement, or also known as metathesis, which uses the formula AB plus CD yields AD plus CD. An example of double displacement is H3N plus BaOH2 yields H2O plus Ba3N2. Now onto the last topic of this video lecture, which is specific types of chemical reactions. The specific types of chemical reactions are chemical reactions that are categorized from the general types of chemical reaction. Direct combination reactions have in total 6 specific types of chemical reaction. First is the combination of metal with oxygen. In the formula, it's metal plus oxygen yields metallic oxide. Examples include 4Na plus O2 yields 2Na2O. Next is combination of a non-metal with oxygen. Non-metal plus oxygen yields non-metallic oxide. Examples is C plus O2 yields carbon dioxide. Next is the third, which is combination of a metal and non-metal. Metal plus non-metal yields ionic compound. Examples include 2 potassium plus chlorine gas yields 2 KCl. Combination of a metal and non-metal. Non-metal plus non-metal yields covalent or molecular compound. Examples include 3N2 plus H2 yields 2NH3. The fifth specific type is combination of an element with a compound. Element plus compound yields new compound. Examples include 2O2 plus CO yields 2 CO2. Combination of two compounds. Compound 1 plus compound 2 yields new compound. By the way, the compound must be different from each other. Examples: K2O plus H2O yields 2KOH. Now, onto the specific types of chemical reaction of decomposition reactions. First is decomposition of a metallic oxide. Metallic oxide yields metal plus oxide. Examples: 2NgO yields 2Mg plus O2. Next is decomposition of a non-metallic oxide, which is non-metallic oxide yields non-metal plus oxygen. Examples include 2N2O yields 2N2 plus O2. The third specific type of decomposition reaction is decomposition of an ionic compound. Ionic compound yields metal plus non-metal. Examples include Ba3N2 yields 3Ba plus N2. The fourth one is decomposition of a covalent or molecular compound. Covalent compound yields non-metal plus non-metal. Examples include 2PCl5 yields 2P plus 5Cl5. Next is decomposition of a chlorate. Chlorate yields metallic chloride plus oxygen. Examples: 2KClO3 yields 2KCl plus 3O2. Is the decomposition of a carbonate. Carbonate yields metallic oxide plus carbon dioxide. Examples include CaCO3 yields CaO plus CO2. Then next is decomposition of a bicarbonate. Bicarbonate yields carbon plus water plus carbon dioxide. Examples include KHCO3 yields 2K2CO3 plus CO2. Next is decomposition of hydrates. Hydrated salt yields anhydrous salt. Examples include SO4 5H2O yields CuSHO4 plus H2O. Next is the single replacement. The specific types of single replacement, which is replacement of a metal by a metal. Metal 1 plus compound 1 yields compound 2 plus metal 2. Examples include 2K plus CaCl2 yields 2KCl plus Ca. Also, Al plus NaNO3 yields no reaction. Why? Because we need to observe the element if they fall onto the metals or halogen. Now, onto the second specific type of single replacement, which is replacement of hydrogen from water. Metal plus water yields metallic hydroxide plus hydrogen gas. Examples include K plus H2O yields 2KOH plus H2. And then Zn plus H2O yields no reaction. Third is replacement of hydrogen from steam. Metal plus steam yields metallic oxide plus hydrogen gas. Examples include Mg plus H2O yields MgO plus H2. Also, nickel plus water in gaseous form yields no reaction. Now, onto the replacement of hydrogen from acid. The formula is metal plus acid yields salt plus hydrogen gas. Examples include 2Al plus 6HCl in aqueous form yields 2AlCl3 plus 3H2 in gaseous form. Cu plus HCl in aqueous form also yields no reaction. Next is the replacement of halogen by a halogen. Halogen 1 plus compound 1 yields compound 2 plus halogen 2. Examples include Cl2 plus NaBr yields NaCl plus Br2. Now, onto the last general type is the double replacement. The specific type of double replacement includes the displacement of a compound by another compound. The formula is compound 1 plus compound 2 yields compound 3 plus compound 4. Examples include Al2 SO43 plus NaOH yields AlOH3 plus Na2SO4. Next is the neutralization reaction, which is acid plus base yields salt plus water. Examples include 2HCl in aqueous form plus BaOH2 yields BaCl2 plus 2H2O. Lastly is the combustion reaction, which is can be divided into two categories, which is the organic compound plus oxygen gas yields CO2 plus H2O. This is called complete combustion. Next is the organic compound plus oxygen gas yields CO plus H2O yields incomplete combustion. An example of combustion reaction is 2C2H6 plus 7O2 yields 4CO2 plus 6H2O. Thank you for listening to this video lecture of mine. My name is Charson Chen from class 11 IPA-B. Thank you for listening and forgive me if there is any mistakes in this video lecture. Goodbye and thank you.